choice review. I know, like, where the direction. What point did Okay, so looking at page one.
Well, at least it did something.
Let me highlight
Exactly.
derivative topics first. So we're working towards finishing off this packet in preparation for Monday's multiple choice quiz. So let me just read through these other derivative topics. Limits and continuity and L'Hopital's rule. So they all kind of go hand in hand. Product chain quotient rule, implicit differentiation theorem such as EBT, mean value theorem, and rules. Related rates, being able to interpret a derivative graph. First derivative test for concavity. Second derivative test. Remember, second derivative test is a test for relative max, relative min using the second derivative function. It's not the same thing as test for concavity. Particle motion, being able to work through problems involving position, velocity, or acceleration. Trig and natural log derivatives. Sometimes with log functions, we always want to consider expanding out using log properties before we jump into our derivative rules. Derivative of inverse at a point. This is where we create our chart and work our way through the chart to build that relationship between a function and its inverse. Linear approximation, this is where you find the tangent equation, and then you plug the decimal value that they give you back into that tangent equation. And then the second half is, the second portion are the integral topics, Riemann sums, trapezoid approximation, integration rules like U substitution. There's no long division. The most you got to do is synthetic division, or trig. First theorem, second theorem, average value theorem, solving differential equations, being able to work with slope fields, and then our final topic for this semester was area volume, finding area, finding volume using disk, washer, or cross section. So let's start off with. So our goal for today is we're going to try to work through as much as between pages 1 through 8, and then whatever we don't finish in class, you guys will do for homework. So tomorrow I'll check pages 1 through 8. We want to be able to get through this packet by Friday, and then I will pick these packet up on Tuesday. Okay. So number one, the graph of f is above, at which value is the function continuous but not differentiable. So continuous means it's got to be connected, but not differentiable means it's not part of the smooth curve. What can we say? Okay. Yeah, so the graph is continuous at point A, but not differentiable because the slope doesn't exist at point A. Right. Okay, number two, the function is defined above. Which of the following is true? Function is continuous. There's a removal of discontinuity. There's a jump discontinuity, or there's a discontinuity due to vertical asymptote. So what I like to do is I like to build my continuity conditions, because if I can go through my continuity conditions, then I'm going to know exactly what's happening. Is there a hole? Is that hole getting filled in? If there is there a vertical asymptote, or is the graph completely continuous? So just as a reminder, our continuity conditions. The first condition is, does the point exist? Second condition, does the limit exist? And then the third condition, we're really not creating any new data. We're just comparing what we've gathered above. Are these in agreement? Does a point exist? Does a limit exist? And finally, does a limit live where the point exists, where that point is filling in where the limit is? So. Okay, so first condition, we know our C value is 2. So I'm just going to go through and say f of 2 is equal to 7. That is, it passes the first condition. The point definitely lives there. Second condition, does limit exist? Well, let's just go through our limit process. Limit as x approaches 2 of the function here. So remember, the first thing we do with limits is always direct substitution, right? We don't know what's going on there. Is there a hole? Is there an asymptote? Is it connected? So if I plug 2 in, the result is going to tell us what's happening there. So if I plug 2 in, I'll get 8 minus 6 minus 2, which is 0. 0 over 0, what does that tell us? There's a hole. The limit does exist, but we keep going, right? So now you have some options in front of you. You can either go through factoring, reducing, or you can go through L'Hopital's rule. I think we probably prefer L'Hopital's rule. It just feels faster. So derivative of numerator is 4x minus 3. The derivative of the denominator is 1. Evaluate the limit at 2. I get 8 minus 3, which is 5. So my order pair is at 2, 7, but my limit is at 5. So is it continuous? Not continuous, right? So what does that tell us? Yeah, what type of discontinuity? Well, jump discontinuity will be like if there's a vertical asymptote or if there are two branches that are not connected, right? But here, the limit exists, so maybe the graph looks something like this, where at 2, if the limit exists, that means the graph is going to connect to that point from both sides, but it just so happens that the order pair is living up here at 2, 7. So what type of discontinuity is this? Yeah, removable. So not continuous, not a jump discontinuity, and not a vertical asymptote. Number 3, we have a piecewise function. We have functions on either side of 2. So in order for a limit to exist, the graph has to connect from both sides, right? So the limit as x approaches 2 from the left has to arrive at the same y value as the limit as x approaches 2 from the right. So we're really just testing the limit as x approaches 2 from the left or from the right of both these functions. Remember, if you see one side of limit, you don't do anything different. You're just plugging in that integer value. If you get a real number, then we don't do anything unique with that one-sided limit. But at this stage, we're just seeing are these branches headed towards the same y value. If they are, then the limit exists. If they're not, then the limit does not exist. So if I plug 2 in for x, I get natural log of 2. So this is where the graph is headed from the left side of 2. From the right side of 2, if I plug 2 in for x, I get 4 natural log of 2. And natural log of 2 and 4 natural log of 2 are not equivalent. They're both headed towards different y values. This is a jump discontinuity, and so therefore the limit does not exist. Number 4, this looks like a pretty complicated limit problem, but maybe it's L'Hopital's rule, but we don't want to assume anything, right? Maybe the limit does exist by plugging in pi, but we only do L'Hopital's rule if direct substitution leads us to 0 over 0. So let's start off with direct substitution to see what we get. Cosine of pi is -1, sine of 2 pi is 0. So we do get 0 over 0. That tells us that there's a hole in the graph. The limit does exist. We just have to go a little further. So this fulfills the condition for L'Hopital's rule. We can apply L'Hopital's rule here. Derivative of each term, cosine becomes negative sine. Sine of u becomes cosine of u times u prime. The 1 goes to 0. X squared becomes 2x, and then pi goes to 0. Once we found the derivative of the numerator and denominator, we can reevaluate. And now the hope is that through L'Hopital's rule, we can arrive at a real number. So sine of pi is 0. That wipes out. Cosine of 2 pi is 1. 1 times 2 is 2. So 2 over 2 pi is just 1 over pi. Okay, number 5, we're still dealing with limits, but if we're looking at infinity or negative infinity, we don't do direct substitution, right? We switch gears. We have a different set of rules for infinity. We compare degrees, right? So here, what's the degree of the numerator after everything is said and done? 2. Denominator is also 2. So we know that if the degrees match, then the limit is just the ratio of the coefficients, right? So it's just going to be √9 over 1, which is just equal to 3. You pass. No, I don't. Number 6, x approaches a. So think of a as your number. It could be like 3. But a is the value that we're plugging in for all the x's. So replace every x with a. So again, number 6, it looks a little bit different, but we're just treating the constant a like if it were a number that we're more familiar with. But this is still 0 over 0. This is also condition for L'Hopital's rule. So take the derivative. Remember, a is a constant here. So x becomes 1. A goes to 0. X cubed becomes 3x squared. What's a cube's derivative? Also 0, right? We don't do 3a squared because that's like saying 2 cubed, right? It's just the number. That number goes to 0. So as soon as we go through L'Hopital's rule, we reevaluate our limit, 1 over 3a squared. Number 7, we should just be able to rely on power rule to get through. because there's only one term in the denominator. We should have to bring that up, merge it into one variable, and then go through our derivative. So this is really x cubed over x to the 1/3. And if I subtract the exponents, I can merge the two together. So basically it's 9/3 minus 1/3, which is 8/3. So we just find the derivative at this stage here, going through power rule, f prime is just 8/3 x to the 5/3. We just have to find the variation that matches from our answer choice here. Now, cube root of x to the 5th, that means the same thing as this, right? X cubed times x squared. We know that we have enough x's to pull a full x out, but there's not enough x's here, so we can take out an x, but then the x squared has to stay inside. So 8/3 times cube root of x squared. We're writing it this way so that we can match our answer choice that's provided. So number 8 is presented a little differently, but it's using knowledge that we've learned. So let's talk about this here. It says f and g are differentiable functions, so they're both continuous, they're both smooth curves. G of x is greater than 0 for all x. So we know that g of x is always positive. We know that f of 0 equals 1. And then they say that h of x equals f of x g of x, but then h prime is f of x g prime. Now, ignoring initially that h prime is just f times g prime, if you're just given this to begin with, and if I asked you to find the derivative, what would your instinct be? What would you have? Product rule, right? So let's build out product rule and compare what we know with product rule with what they're telling us is the resulting value. So normally we would say, well, h prime is going to be f prime g plus f g prime. Right? We know that this should be the derivative, but then they're telling us the derivative is only f of x g prime. So they're saying that the only thing that remains is this. So what does that mean then? That why would this disappear? Right. Something is causing this to zero out, right? But we know that it can't be g of x because g of x is a positive number. So therefore, what do you know about f prime? F prime must be 0, right? This is what's causing this to disappear. So you know that f prime of x must be equal to 0. So if f prime of x equals 0, that means f of x must be a what? Must be a constant. There's two constants here, 0 and 1. So which one would this be? Because they tell us f of 0 equals 1, so we're able to make that connection. So this is kind of like a roundabout way of testing students' knowledge of product rule and then kind of going through problem solving steps to get to our answer. Number 9, let f be a differentiable function. So we know we're dealing with a smooth curve. We have an order pair given. We have a slope value given. And then they tell us that g of x equals x of f of x. Which of the following is the equation of the tangent line to the graph of g at x equals 2. So we're trying to find not the slope of the tangent line of f, we're trying to find the slope of the tangent line at g. So we have to find the order pair at g using the data given, find the derivative of g, plug in using the data given. So if I want to find g of 2, I can just plug into this function here. Let's get that out of the way. We know f of 2 is 3, so 2 times 3 is 6. And if I want to find g prime of 2, I first have to find g prime of x. To find g prime of x, what do we need to go through here? Product rule, yeah. So let's build out product rule. F prime times g plus f g prime. Once we have our derivative, replace every x with 2, and then we should have enough data to get it down to a numeric value. F of 2 is 3. F prime of 2 is -5. 2 times -5 is -10. -10 plus 3 is -7. So we have our order pair, 2, 6. We have our slope at -7, point slope form. All right, number 10. They're asking you to find f double prime, but let's start with f prime. Tangent becomes secant squared u times u prime. U prime is asking for the derivative of e to the 2x. E to the 2x becomes e to the 2x times 2. Okay, I'm rewriting it in a way that can help us set up for our next derivative. We see that there's a need for product rule here, product and chain, because secant squared, we got to go through that inside and outside inside portion. Right? All right, a little messy here to get to the second derivative. All right, 2e to the 2x becomes 2e to the 2x times 2. G stays the same. F stays the same. All right, G prime is where we have to go through our whole chain rule part here. Bracket squared becomes 2 bracket to the first power. Secant of u becomes secant u tangent u times u prime. U prime is asking for the derivative of e to the 2x. And remember, for e to the u, the rule is e to the u times u prime, so it'll be e to the 2x times 2. Let me do some cleanup here, and I want to show you what they're doing to get to the answer choice that they're trying to get us to match up with. So I'm just pushing all the coefficients together here. Oh wait, there's more than that. My bad here. 4 times 2, it should be 8. Right. So I'm multiplying the 2, this 2, and that 2 together. 8. So if you look at the answer choice, it may not seem apparent as to which one is going to match up with what we have so far. Now, this is what has been done in terms of cleaning up. Think of these as two extended terms, right? And what's happening is they are identifying a GCF and pulling it out to make it a little cleaner for their answer choice. So between these two extended terms, what's a common factor that is shared between these two terms? Yeah, 4e to the 2x and secant. Yeah, so I'm essentially just going to take out that GCF. And if I take out a GCF, that means I'm dividing this away from the initial terms, and whatever is left over goes here, right? So if I divide this by this, I'm just left with what? If I take out a GCF of this from this, I'm just left with 1. And if I divide this second term by this GCF, this goes away. The 4 and 8 reduced to be 2. The e to the 2x goes away. The only thing left is just 2 tangent e to the 2x. Oh, my bad. Yeah, sorry. There's another e to the 2x that's sitting out here. So when this goes away, the 4 and 8 would reduce to be 2. Secant goes away, but then the tangent e to 2x and e to the 2x stays. So okay, number 11. The figure shows the graph of the function g. Tangent at x equals -1. So we see that the line is not only sharing the same y value as the curve, but it's also sharing the same what? Because it's tangent. What else does a line and the curve share? Yep, point and slope. Yep. If it's tangent, that means this curve is matching the same slope as this line, right? Okay, so that's something that I'll keep in mind. We want to find h prime of -1. So let's first find our way to h prime of x. So to get to h prime of x, we see the need for product rule, right? We have two separate terms that are being multiplied. So f prime times g plus f g prime. Replace every x with -1. Now, g of -1, that's easy. That's just the same. That's just the y value, 3. But g prime of -1, that's asking for the slope of the g graph at -1. How can I find the slope of the g graph at -1? Yeah, find the slope of this line, right? If I can find the slope of this line, then it's got to be the same as the slope of the curve. So we do rise over run, change in y over the change in x. 3 minus 3 over 0 minus -1. So my slope of that line is -6. So therefore, I can conclude that g prime of -1 is also -6. So I'm left with 3 over e minus 6 over e, which is -3 over e. That's our answer. Okay, number 12 is a calculator question here. Let f be the function given by f of x equals 3. Sorry, 3 natural log of 2x. And let g be given by g of x is x cubed plus 2x. At what values are f and g have parallel tangent lines? So parallel means that what? Slopes are the same. So essentially that's same thing as saying when the derivatives are the same. All right. So we just have to figure out when do the two graphs have the same slopes. So we can just find f prime and g prime, basically set them equal to each other. So f prime is just 3 times 2 over 2x, which is the same thing as just 3 over x. G prime power rule, 3x squared plus 2. So we just want to know when is 3x squared plus 2 equaling 3 over x, right? What x value will allow these to be the exact same number? So we're trying to find out when is 3 over x equal to 3x squared plus 2. This is not an easy equation to solve by hand, but this is a calculator question. So what we can take advantage of, especially if we don't have easy algebraic skills, is let's just bring everything to one side. We know that we can always look for the x-intercept. I think I prefer that way. Another way that you can do it is you can graph both curves and see where they intersect. But then if you do that, you may have to kind of search search along your graph to find that intersection. I find it a little bit cleaner to just bring everything over to one side, and that way you can just graph and then just look along the x-intercept. I think it's a little bit easier to just focus, just kind of look, where to look rather than having to search all over, the different quadrans to see where your graph intersect. So that's my strategy there. Just make the calculator look for an x-intercept. So under y1, I'll type in 3x squared plus 2 minus 3 over x. And if you look at all your x values here, these are all the potential solutions here. So I'm just gonna set my window to values around this. I know that it's got to be one of these x values here. So I'll just go from, let's say, -1 to 2, maybe, or -1 to 1. So wherever that x-intercept is, that's the solution that I'm looking for. So second trace, 0. Choosing a point to the left of the x-intercept, hit enter. Choosing a point to the right of the x-intercept, hit enter. I got 0.782. Try 13. 13 is the same strategy as 12. So we find f prime, we find g prime, set them equal to each other, bring them over to one side, graph that equation, that graph, and look for the x-intercept. Okay, page 4. Let f be the function defined above, where c and d are constants. If f is differentiable at x equals 2, what is the value of c plus d? So they tell us that f is differentiable, meaning that the graph, the two piecewise functions are not only going to connect with each other, they're going to connect in a way where the slopes are also matching. So the strategy here is we're going to set the equations equal to each other, replace all the x with 2, find the derivative, set the derivatives equal to each other, replace all the x with 2s. And then we should be able to use the two equations to help us solve for c, and then solve for d, and then we can add them together. So let me just find f prime, and then we can have everything that we need to set equal to each other. Remember, treat c and d like constants. So pretend like c and d are like 2 and 3. So however you treat 2s and 3s, that's how you're going to treat c and d. So what's the derivative of cx plus d? The c, right? Imagine it was 3x plus 4. You would just say 3, right? The d doesn't go to 1, the d goes to 0. What's the derivative of x squared minus cx? Yeah. Okay, so we'll set these equal to each other, replace all the x's with 2's, set these equal to each other, replace the x with 2's, and then we should be able to just algebraically solve for C and solve for D. Sorry, 2C, not 2x. Okay. C equals 2x minus C. Again, plug in 2 in for x. So here I can just solve for C. C should be equal to 2. And if I plug 2 in for C, I get 8 plus D equals -4. So now we have everything that we need. We have C is 2, D is -4. We add those together. C plus D is -2. $15, what is the average rate of change? No calculus here. We're just finding slope. So average rate of change is just f of B minus f of A over B minus A. If the line tangent to the graph at the point 1,7 passes through the point -2, -2, then f prime of 1 is equal to. Well, if the line is tangent to the graph, that means the curve and the line will share the same slope. So the slope of the curve at that point is going to have to match the slope between these 2 points because of that word tangent. So we know f prime of 1, even though we don't know the curves equation, we know that all we need is these 2 points to help us find, to match the slope. Okay, so we worked through about half of the assignment. Tomorrow, we'll walk around and check you off for learning points towards your quiz. So pages 1 through 8. Thursday, we'll work on pages 9 through 16. And then Friday, we'll work on pages 17 through 22. If you don't finish it in class, you can turn it in on Tuesday. And then Monday is your multiple choice quiz. And then I'm going to have a help session Friday morning and Monday morning. I have some additional practice tests that College Board has released from previous years. So if you come in, we can just pick out problems from there. Just giving you some additional problems to work on. Okay, I'll send out a reminder this afternoon. I'll be checking pages 1 through 8 in this packet. All right, we'll get you thoughts. Yeah. Thank you. Oh, yeah.
Would it be like, is that question like the last minute information on like which?
You get the morning review?
Yes,
Yeah.
it's basically. Cool, because I'm wondering if you have to do this examination or.
Yeah. Maybe, but it's mainly
Just like.
yeah. Maybe one.
I think there's someone else talking. That is really embarrassing.
You can say, yeah, you can remember that.
I got a different. There's like 21 on it. I got that. That was. Oh, probably.
That's the one.
Should be closer than that. Yeah, let me see your.
Y'all probably be on stage tomorrow. And Oscar. Oh my God, so fun.
Oh.
I'm excited about it. I'm sitting home.
We spent like years over my house and 30 to 9 doing propaganda the entire time. Actually, we did take a breaks like.
What's the currency replaced by the euro illegally? Euro? I knew it.
They're the anti-derivative. There's hardly any gallons to say. Just got to spend for your showing. What's the 27 derivative? So.
We tried hard.
It's good. It's already given to you in gallons per second. So you already know that means it has to be.
It's not later. Also, we
Gallon per
spelled
second,
it.
you can take derivative of gallons. So
Yeah, liar. Wait, what?
take derivative means.
Go ahead.
I know it's There's a order of operations. So then we use those.
Yeah. Yeah. Gallons per second.
Oh, beans.
You're doing average value.
Beans.
Like,
Oh my God.
this right here is gonna cancel out this, so it's gonna stay the same. After you see average value.
We already showed up. We already tried.
Let me do that. That, it may be providing and multiplying in ways that you can expect. Yeah, so alpha white. Sorry, alpha white equals what gets that fraction. Otherwise, you have to use more parentheses to get also.
On the right, Michael.
Keep that in mind.
Kill on the right. Kill on the left.
It's my find out once I think this is for that.
So true. So real.
You, let's see, you have,
That's my dream
do you have install here?
Vending machine. That is my dream.
I'll try to get
Trust. Bro, it's gonna scroll through my photos. Yo, James. Can't wait to go to the barber.
Oh, good.
Oh, yeah, Xavier, you got down here. So I got like machine.
Literally, I think I was always like,
Yeah, then I guess I got to pay for something like money. So yeah, it's absolutely tragic.
we have. I did say shit. We got our notes in a burner for at least years. But I said, no, we didn't get that last time. I got 50 on last time. And we didn't get a burner.
Yo, I might do the
That's exciting.
rail. I don't know what the two.
That's what's causing the issue. Which is the order of operations is throwing.
So I just have to put it.
Yeah. So. Yeah, so alpha.
Well, I was gonna say I might do this on my own actually, if I get through this question.
And then when did you?
Seven.
Okay.
Yes, we know.
True. Currently doing research on things to do in. Why are these excursions so expensive? I don't want to spend $200 every single.